Hi guys, so let's start with our lab. So this is our lab which is recognize and synthesize speech. So for that we have to go to portal and create speech resource. So let's go to this here and click on speech, right? And when we go on speech, we can create the speech resource. Let's call this, we can put this in translator lab only, resource group, and we will name it speech resource group. Pricing tier will be free, and then we will review and create, and let's wait for it. After that, what we have to do, we have to go on clone repository, install libraries, and set up our environment variable. So if we see here speech and we create it, so our speech resource has been deployed, and these are the location of it, the keys, and you can see in the endpoint does not mention the resource name, but it mentions the region. So this is the regional endpoint, which is the region name api.cognitive.azure.com or .microsoft.com. So api.cognitive.microsoft.com and the region name. So that is the endpoint. Although in our speech SDK, we will not be using the endpoint here, right? So in the speech SDK, we will not be using the endpoint. As you can see here in the speech SDK, we are just passing the key and the speech region. So endpoint will already like it will infer the endpoint from the region, right? Because the only difference will be that East US will change to West US, right? Or it would change to something completely different, like Canada East or Canada West, Canada Central, right? So that is the region name here, and from that in region name it like automatically infers the endpoint. So that is why we don't need to specify the endpoint. We just specify the region and the key in our speech SDK, right? So let's initialize these libraries. Like first of all, clone the library, right? So let me do these steps. So I have done all these steps. I have basically cloned my repository, went to this directory, create a virtual environment and install libraries. So what library we are installing? We are installing Azure Cognitive Services Speech, right? So it is Azure Cognitive Services Speech and a particular version of this. And then what we have to do, we have to enter the region and key. So here we have this our speech API. So let's copy the key and paste the key here, right? So we paste the key here, and then we have to paste the region, which is East US 2. So we will paste this also here, right? We'll save it and quit it. And the next thing, uh, we are opening speaking clock.py. So we are creating a speaking clock, right? So code speaking clock.py. So this is our code here. First of all, we need to import namespaces. So let's see what are the namespaces. So because this is cognitive services speech, and we are importing speech SDK from it, right? So let's do that. So from Azure dot cognitive services. So which was the previous service, right? Of Azure cognitive services, right? So Azure dot cognitive services dot, that is speech, right? So we are importing speech SDK, but this will be speech only. Yeah, that is speech. So Azure dot cognitive services speech import speech SDK, right? And then we will use this speech SDK. So here we are putting this global speech config as global. Here we will configure our speech service. So to configure our speech service, we will do speech SDK, and in speech SDK we will specify our region, right? And besides region, we will specify our key. So speech key, right? That will be speech key, and the next will be speech region. So this will give us, let's see, this will give us speech config object. So this will give us a speech config object, speech config object, right? So this is our speech configuration object. And now let's see what we have to do next. The thing to note here is that I have incorrectly used this. So this is the incorrect usage. So when we imported the speech SDK from Azure Cognitive Services.speech, it is basically we have to treat this as an SDK, right? This is not a service client. So here in speech SDK, we have to, it's not a constructor, right? Here we have to uh, put it as speech config. So it is basically a speech configuration object. We have to call this method speech config, which will take a key and a region, right? So here, as you can see, this is dot speech config. So this is the region. And afterwards, what we have to do? We have to check where the speech configuration will run. So it will basically run in the same region we have specified, right? So the region speech config dot region, right? So yeah, we will ready to use speech service in this region. So ready to use speech service in this region. So this is the configuration of the speech service with which object speech config object. So we are using speech config object to basically configure our speech service. With here we specify the key and the region. And this is basically speech SDK. So speech SDK is used for both speech recognition and you know from text to speech and speech to text. It is used for both. So that is why we have a speech config object, which is basically taking care of the key and the region. Now what we have to do after that, we have to basically transcribe command. So here the command is empty initially. First of all, we need to configure our speech recognition. So here what we will do, we have the speech config which is global, right? So that's why we can use it here in this function. So in speech config, right, also in SDK, speech SDK, we have this audio config. So audio config, and in that audio config object we will give the file name. So file name from where the uh, so it this will be the file name from which we want to extract, right? The audio file from which we want to transcribe. We have to specify that audio file here. So let's see, are we correct or not? So here what we will do, we will pass the audio file. So for audio file, this is the file that is in our directory. So we will do that. So let's copy paste this and understand what it's doing. So here you can see our current file, current directory, we are getting it from get current working directory. So get cw. From that current directory, we are concatenating it with time.wav wave, right? So this is our audio file. So this will be the path of our audio file. Now we are passing that path of audio file to our file name, right? And we are using speech SDK dot audio config to create our audio config object. So here we can say creating audio config object, audio config object, right? After creating our audio config object, next thing is we have to basically create our, we have the speech config, we have the audio config. Now we have to create our service client. So for that, what we have to do, we will pass both of these objects in speech SDK dot audio config and speech config. So both of this will be in a client. So that client would be speech recognizer. So we'll put that in speech recognizer, speech recognizer, recognizer, in which we will pass our speech config, right? And audio config. So audio config has our audio file and speech config has our and our key and the region, right? And this will give us the client for the speech recognizer client. So speech recognizer, basically this is the speech recognizer. So we have created our speech recognizer, and this is our SDK. Now the next thing is we have to process the speech input. So whatever the speech input is, we have to process it. So now we can process that speech, like we will use speech recognizer. So that is our client now for recognizer, for speech recognition. So here we will use the method that will be once, async once. So it will basically, let's see the method here. So recognize once async, right? So we are, this is a speech recognizer, so that is why, so method will be recognize, recognize, and recognize async. So it is async and once. So that is the thing here. Let's understand what this method means. So first of all, recognize once async. So yeah, that is the order. So it's first telling that we are recognizing only once, and then it's telling it is async. So let's understand what that once and async means. Right? So we understand what recognize means. So here we have different methods for our speech recognizer class, and it takes speech config and audio config objects. Speech config is the required object, right? And then let's understand what this recognizer once and what this start continuous recognizer once async means. So for that, it is easy to understand if I go to my prompt. So first of all, we need to understand what is utterance. So one complete spoken segment by a speaker is utterance. So like if I speak hello and stop, so that is an utterance. If I speak hello, how are you, then that is an utterance. If I speak like hello, how are you, it was nice to meet you, so hello, how are you is one utterance. So when you stop talking, that is an utterance. And the service detects silence. So whenever the service detects silence, it will treat it as an utterance. That utterance has been completed. So if I say hello, how, and I stop, I take a pause, so that will be considered an utterance. So it is like something you spoke without taking a pause. That is an utterance, right? That is one utterance. Whenever you detect a pause, or the person has stopped talking, so that would be considered as an utterance. Or there is another thing, if 30 seconds pass. So if I am speaking continuously a lot, right? But while I am speaking, the 30 seconds have already passed. So this is the Azure limit for single utterance mode. So after 30 seconds pass, doesn't matter you are speaking or you haven't stopped speaking, it will still cut the speech there, and it will be counted as one utterance. It will cut that spoken segment there, and that will be counted as an single utterance, right? So when we mean once, right? So one sentence you say, so utterance can be a one sentence you say, one phrase, one chunk of speech before pause, one breath long speaking part. So all of this can be considered as an utterance. So if you say hi, pause, that is an utterance. If you say hi, how are you, that is also one utterance. So this is the utterance. So let's see, there are two kind of modes. So if you want to recognize one utterance, then you use recognize once, right? This is good for those commands like for Siri, or like for those kind of the speaking bots, like Siri, and there is one more, I don't remember the name, but yeah, Siri. And so we basically use recognize once when we have to recognize one utterance. If we want to recognize more than one utterance, then we use multi-utterance recognition mode. So in multi-utterance recognition mode, it keeps on listening continuously, no matter you take pauses, right? So it basically is useful when you want to handle transcripts, meetings, long audio. Then you use multi-utterance recognition, right? There you use start continuous recognition. So to basically start the continuous, And then you also have to use stop continuous recognition. So when you want to stop the recognition, because it is not stopping, like in utterance it stops when you take a pause or when 30 seconds are over. But in start continuous recognition, it won't stop until you specifically, explicitly call stop continuous recognition. So that is one thing that we see here in the documentation. We have recognize once, and we have start continuous recognition and also stop continuous recognition. And here is start keyword recognition. So like if there is a keyword like Siri and then we speak, so it basically starts with the keyword and ends with also the keyword, right? So that is the keyword recognition. So now these both of these can be done synchronously or asynchronously. So if it means synchronously, that it means that you are blocking, you are in a blocking mode. So once the processing has been completed, only then the result would come. In async, it means that it will give you some object, right, from where you can track the status, that whether the thing has been like whether the job has been completed or not. So that is the meaning of async. So it's basically asynchronous and synchronous mode. And now if it is an asynchronous mode, so this basically returns us like if we go to recognize once async, this returns us a uh, future, right? Future result, like how we use promises in the you know JavaScript, if you know. So in result future, so if we go to result future here, let's see our result future in the documentation, PQR result future, right? So if we go to result future here, we can see there is a get function. So this get function will basically return whenever the result is ready. So we will use get with it. So yeah, so that is how we will use recognize once. So as you can see here also, we are using recognize once async and then we are using get on it. So it will, once the job is completed, only then it will give the result in speech. And what kind of result that will be, right? So let's understand what kind of result that would be. So speech recognizer class, basically if we use recognize once async, it returns us this class, which is speech recognition result class. So in speech recognition result class, we have these attributes: cancellation details. So if our job is being cancelled because of any error, so this cancellation details attribute will have all the information. Then there is other properties, which is reason. So recognition reason. So what is the reason for your recognition, right? That is being returned in this reason. So there are different types of recognition reason. Let's see them. So here is result reason enum. So the result reason could be cancel ID. It could be no match. So there was no match, right? And there, it means it didn't even recognize that there was a human speaking. So that is no match. Then recognize keyword. So if you have set it to recognize a keyword, then it has recognized the keyword. Recognize speakers, recognize speaker, recognize speech. So this is what we are looking for. Recognize speech. There is recognizing intent, keyword, and more of these things. Translate speech is also one of the result, right? Translating speech is also one of the result. Translated speech. All of these are in result reason enum. So in result reason, we will go with recognized speech. So as you can see in the code also, we have result reason dot recognize speech in the speech SDK. We are comparing it with the speech dot reason. So speech dot reason is this reason in our speech recognition result class. So that is the speech dot reason. So if we have the recognized speech reason, then we are basically extracting the speech dot text. So you can see in the result also there is a attribute called text. So this is the text that is being generated by recognizing the speech. So this is the text generated by recognizing the speech, and then this is the reason. And for the cancellation also, there is like speech dot cancellation details, and in cancellation details also you have the attribute of reason and error details. So all of this is to basically transcribe your speech into text. So now let's try to see. that once we have come up with speech recognizer dot recognize once async, so what are the parameters that we have to pass? So we do not have to pass any parameters in this, and from dot get we will basically get it because this is asynchronous, so we will get it when the results are ready. So let's call this as speech results, speech recognizer results. So speech recognizer results. So we can call the speech recognizer results, or we can also call it speech also. That's also fine. So we have the speech here. Now what we want to do with it? So in the speech, we want to see what is the reason for it, right? So speech dot reason. We want to check if this speech dot reason, right, is this equal to our, we have a result dot reason, right? Result reason, which is an enum. So we can see here result reason enum. So in that result reason enum, we want the reason to be speech and speech recognizer. So speech recognizer, that is the thing. So here it is recognize speech. Yeah, not speech recognizer, recognize speech. So result reason is recognized speech. So this is the recognized speech. And when we have this reason, so if this reason is there, then we will extract speech dot text, right? In that case, we will extract the speech dot text. Else, if it is not, else if it is not that, right, then we will see for the error. So let's see here. If speech dot reason is, yeah, we have to use this with speech SDK. So this result reason is in the speech SDK. Speech SDK dot result reason. So that is what we are doing here. So if speech dot reason is equal to speech SDK dot result reason recognize speech, then this is the command. So this command is basically the, we are calling it a command because this is uh, just once, right? This is just one, what we say it. Um, let's see. So this is just one utterance, right? So because this is one utterance, that is why we are calling it a command in our code. Here we are calling this command because this is just one utterance. So it is like a 30-second or less than 30-second utterance, right? So that is why we're calling it a command, and we are like putting it in our command variable. And if that is not the reason, right? This recognize speech is not the reason, then we will see is the reason cancelled, and in case it is cancelled, then we will go on check the cancellation details. So let's basically copy this code here and use it with here, right? So this is the process speech, and if we can do this, nice, process speech input. So this is our whole code, right? So this is the code. Now this will return the command. So command is basically whatever it is recognized by the speech.text, like whatever is spoken, and whatever spoken is being translated into text, that is our command. Now next we will run this by saying control S. We will run this, and this is the audio. So basically,
What time is it?
so in the audio the person is saying what time is it. So if we go here and run python speaking clock.py, let's see import error speech SDK from Azure.cognitive services. Okay, let's see here. What's the error? Cognitive services dot speech, Azure.cognitive services dot speech. So we have imported this only, I think, from Azure Cognitive Speech Services. Import this. Okay, so we are importing this as speech SDK. It's not that we are importing this from this. We are importing the whole library as speech SDK. So it is not like from this import this, it is just import, right? And now let's do CLS, and now let's call this again. So it's listening. So as you can see, what time is it? The time is 1:57. So in the audio it just said what time is it, it's listening and it says what time is it, right? So that is the thing here. And also the time is 1:57. Okay, now next let's see. So we have configured our speech service, we have put our audio config object, we have created our speech config object, put that into speech recognizer, and then with speech recognizer we are seeing the results, right? And now the next thing is we have to synthesize speech. So for that we have to go into the tell time function. So this is transcribe command function. Now this will be a tell time function. So here we have to configure our speech synthesis. So for speech synthesis configuration, let's see what we have to do. So let's understand here, in configuring speech synthesis, we again have to use our speech config object and the audio config object. So for audio config object, we will use speech underscore, right, SDK, which is the thing that we imported, right? The Azure Cognitive Services dot speech. We imported it as speech SDK, right? So here we are doing it as speech SDK, and now we will do our audio config object. So audio config, and here we will pass our file name, but we have not created any file, right? So first of all we have to create a file, and to create a file what we have to do, we have to name a file. So let's name the file as output.wav, right? And then wave file. So this is our output file, and now we also have to specify a persona, right? So this file we like, there will be text, but that text needs a voice. So that voice will be this voice, which is en stands for English, GB stands for Great Britain English, and Ryan neural is basically the persona, which is looks like a boy, right? Ryan is a boy name, and we will use this. So in speech config, our speech config, we will use speech synthesis voice name. So this speech config is our speech config object that we created, like right here, dot speech config, which we pass key and region. There we also need to specify the persona, and for specifying our voice name, there is an attribute speech synthesis voice name. So let's do that. So this will be speech config dot um, synthesis voice name, speech synthesis voice name, right? Yeah, so it will be speech synthesis voice name, and this we will set to uh, this one, engb ran neural, right? So we have set this to this one, and now we have our speech config set to this voice. We have our output file, and we will put the output file here, and in speech SDK dot audio. So here we are using dot audio, whereas when you were using this one, audio config, we were not using dot audio. In this case we will be using speech SDK dot audio. So let's see here, speech SDK dot audio config, right? So this will be our audio config object, and this will be our audio config now, right? This is the new audio config object. We have created the audio config object, but this is from speech SDK dot audio, not from the simple speech SDK. And afterwards we have configured our audio, we have configured our speech. So now it's the time to call our function. So speech SDK, and we are synthesizing speech, so it would be related to something like speech synthesis, right? or yeah, this is speech synthesizer. So the method name is speech synthesizer, and it will take both speech config. So in our speech config, what we have done, we have modified it by changing its speech synthesis voice name, and then there is audio config. So this audio config is coming from speech SDK.audio, and yeah, rest is the same. We are just specifying the file name. So this will be the output file. Now let's do this. So this will basically also this is an asynchronous operation. So that's why we also have to do dot get to get it when it is ready, right? We do not have to do it here. This is our speech synthesizer object. So this is our speech synthesizer object. So let's call it speech synthesizer. Speech synthesizer object. So just like here we were creating the recognizer object, speech recognizer object from speech recognizer. Here we have created the speech synthesizer object from speech synthesizer, right? And now we will use this speech synthesizer to basically create our spoken audio. So speech synthesizer dot, and now we have to synthesize the speech, right? So let's see, speak text async. So this will be our method, speak text async. So speak text async. So this is also async operation, and here we will specify our text. So speech text async, which is our response text, and because this is an async, so we also have to call the dot get method. So response text, and yeah, speech text async response text, and here we will specify dot get method. So here we will get our results, right? So this is speak, so we will get the result in speak, and then we will check the reason of the results, whether it is synthesized audio completed or not. If it is completed, then we will just print the reason. Otherwise we will say, like, if it is not completed, then we will print the reason. Otherwise we will say that spoken output is saved. So let's create this and tab, right? So this has been created. Now let's see, uh, let's try to run our code. So Python, so this is the speech that like the time is 1:57. This will be converted, right? So right now the time might be different, so it would be something different. But speaking clock.py, listening, and then what time it is, what time is it? Spoken output is saved in output.wave file. So if we download uh, output.wave file and click here to download your file, and let's see what is spoken here.
The time is 2:07.
So they say that time is,
The time is 2:07.
yeah. So this is the voice that we have created. Let's try it with another voice also. So now let's move to the another part of this. So which is speech synthesized markup language. So our speech synthesized markup language has a, it's like an XML, right? So this is our speech synthesized markup language. So what we have to do in the tell time function, under the comment synthesize spoken output. So in case of this synthesize spoken output, so here we are basically synthesizing our spoken output. We are going to comment all of this, right? And instead paste this synthesize spoken output. So here what we are doing is, still we are doing the same thing, that is speech synthesizer speak. So we are using our speech synthesizer again, right? So if we copy this and we paste it here, so still we are using our speech synthesizer. So let's uncomment this and also this, right? So what we are doing is we are using speech synthesizer and then we are calling the method speech text async, right? Speak text async. So we are telling it to speak the text async in async manner. So here we are giving the response text and the dot get method to just get out of like the async, right? So when the operation is completed, it will just give the output. So that is what is here. But what we will do now, after that we are checking the result also, like what is the speak dot reason? Is it like synthesizing audio completed? If it's yes, then we will output the file, right? That the spoken output is saved. Otherwise, we will see what is the error by checking the speak dot reason. So now we are doing the same thing here also, but in this case we are using speak SSML async, right? So here we will not be using this. Instead, we will be using this. So we will be using speech synthesizer. So this is our speech synthesizer dot. Then we will be using speak SSML async. So here it was speak text. So that's why it was going to speak the text that we provided in response text, right? But here it is speak SSML. So SSML is a markup language, speech synthesizer markup language. So it will speak the markup language in async manner. So that's why here we have to specify the markup language. And we have not created any markup language. After that we will call .get to get the operation when it is done. So here we will call the markup language. As you can see here, this is our markup language. So we are storing our markup language like this, right? So let's copy this and here we store the markup language in response SSML. So that's why here we will write response SSML, response SSML, and here we will type the response SSML. So here let's understand this markup language. So first of all, there is speak. So speak is basically to speak. So this is our main like main parent. So here we are telling it the version. We are telling it the XMLNS. So this is a link. So the namespace, XML namespace, and then this is the language. After that, what we are saying the voice, and the voice name is Libby Neural. English, Great Britain, Libby Neural. So that is the voice name. So this is the voice, and here we are taking a break, strength weak. So we are taking a small break, and this is the time to end this lab. This is the actual text that we have to speak. So let's try this to understand how it's working. So if we save this, then we will check our output file again, and let's run our code. So response ml. So format response text, right? So our response text was this time is this. So now we have formatted that with our time to end this lab. So response SML is not defined. So yeah, because that is capital S. Okay, let's save and let's run it again. And this time, what time is it? Speak is not defined. Okay, so let's see here. Speeds. Okay, so there speak should be equal to this, right? Speak should be equal to speed synthesizer, right? Sorry about that. Now let's see. So yeah, so spoken output is saved in output.wave file, right? So we will download now output.wave, and click here to download your file. So let's click here. So it has downloaded our file. Let's go to our folder and let's see. I think this one is the file.
The time is 2:33. Time to end this lab.
Yeah, so this the time is 2:33. That is the time to end the lab, right? So it has spoken the same thing here, which we have given, right? So it has used that. Now let's understand the this markup language, like speech synthesize markup language, from Azure's perspective. So we know the break is for pause, right? So strength is weak, so there is a small pause. Voice, so we get the voice was for Libby from Great Britain English, right? Libby Neural, not from Libby, but the voice name is this. And the speak language, so XML language, XML. So speak is the main tag, right? So let's understand. Some of these are like SSML specific. So some of these tags are the specific to speech synthesis markup language, and some of these are extension of Azure. So whenever there's an Azure extension, so Azure follows W3C SSML standard and add powerful extra tags under MSTTS, right? So here you can also see here MSTTS, that means Microsoft Text to Speech. So in this namespace, Azure adds its own tags, right? And let's see these tags here. You know, for Azure tags, we have this express as. So express as basically contains speaking styles. So it could be cheerful, sad, empathetic, newscast, right? And there are like audio adjustments. So for audio adjustments, it also gives us silence and audio duration, just the duration of audio output, and background audio, what if you want to add some background audio or sound effect. Then Vice Me, so this is basically Viz Me event, so basically the lip movements, right, of the face during the speech. So we do not use this, but yeah. Then there is prompt, so prompt basically enable pronunciation rules. And then there is multi-dialogue. So in case of multi-dialogue, you use MMSTS dialogue, and in that dialogue you use MSTTS turns. So for each turn, one of the person will be speaking. So use dialogue and turns together to basically use this multi-talker dialogue. So this is the extension and powerful tool within Azure AI speech service, right? Now let's look at some common use cases, like common tags. Those six most important tags. So first of all, this is the speak, so that is the root element. Then there is voice, so basically tells what kind of voice. So like this is English US Jenny neural. So you must wrap content inside this voice for the voice name. Azure expects this voice, right? So whatever you wrap in this voice, that will be spoken in this voice only. Then that is prosody. Prosody basically has rate. So rate basically tells you how quickly you want to speak or how slowly you want to speak. Then pitch is basically the frequency of your voice. Is it like high pitch like females or like low pitch like males, right? Then the volume of the voice should it be high or relatively low or soft, right? So we can use this quantitative figures like 20% plus 5%, or this relative adjustments, or we can use this soft also. Then there is breaks is for pause, so it also has strength, so like strong, but it can also has time. So like this is 500 milliseconds, so it tells you how long you have to pause. Then say as, so say as is basically interpreting, so like interpret as digits. So you could also say it as 112 12,345, or you could say it as 1 2 3 4 5. So how do you want to say it, right? So interpret it as digits. Then this is read characters. So if you want to read it as characters, so you could say is gypty, or like you can't say this, but yeah, gapped, you can say it gapped, but you want to interpret as correct, so you will say GPT, right? Then that is date. So date is also, you could say like November 2025, 13 November 2025. but the thing is you can also read as 2025 1113. So how do you want to say it? So that is basically the says tag, which is combined with this interpret as attribute. Then there is subtag. So sometimes there is substitute. So like for WHO you want to say World Health Organization, you don't want to say WHO. Then there are Azure exclusive tags, which will be basically based on Microsoft text to speech, MSTTS. So express as is basically the style you want. Do you want it cheerful, sad, angry, news, empathetic, whispering, right? Then there is a degree of style also, like how much degree, right? The intensity of style. Then there is background music. So in background audio, you also specify the source, the volume, and fade out, fade in. That's also there. And then there is silence. So how much silence you want, what type of silence. So silence is of type sentence boundary, and you want the silence for 500 millisecond. So that is also there. Then there is lip sync. There is multilingual SSML also. Then there is audio output format. So all of these are the yeah, speech synthesizer markup language, Azure extensions and speech synthesizer markup language. So what we do in this lab is also the same thing. We use a very simple speech synthesizer markup language with just speak tag, voice tag, and a break tag, right? And we just format it into our response text and we get our response SSML. So from our synthesizer we call the speak SSML async, right? So here it is speaking the SSML. Previously we were doing it with text, right? So it was speak text async. So whatever we get the result, in the result we always check the reason, and if the reason is the reason that we wanted, then it's okay. Otherwise we need to check the errors or those things. And this speech synthesizer and also the speech recognizer, we created it with, you know, these kind of methods. Like here we use speech synthesizer and pass speech config and audio config to create a speech synthesizer. Whereas in audio, in speech recognizer, what we did in speech recognizer, we use this speech recognizer method and pass the speech config and audio config. Here the audio config was just a file name, right? And speech config was just key and region. Whereas in this, uh, in our speech synthesizer, the speech config was the same thing, but we also had the speech synthesis voice name to our speech config. And besides that, in audio config, we also add, audio.audio config. So we need to add the audio.audio config, right? So these are the little differences in both of these approaches. However, these both approaches are very similar. For both of these, you have to first of all create your speech config object. Then you take the speech config object. Then you create the audio config object. Then you use the speech and audio config object to basically pass it into a recognizer, speech recognizer or speech synthesizer. And then you get an object which is speech synthesizer object or audio um, or speech recognizer object. And then you use those objects to basically call your exact function, which is recognize once async, right? And in that case, it is basically speak text async, right? So these are this is very simple lab, right? So yeah, now the next thing is, what if you have a mic and a speaker? So in case this is basically saved as a file, but what if you want it to be go through your mic or your speaker, right? You want speech recognition with your microphone, and you want the speech synthesis in your speaker itself. So for here, what we do here is, if you have a mic, you can use the following code to capture spoken input from speech recognition. So here in audio config, you use default or microphone equal to true, right? So let's try that, right? Let's copy that and let's try to run this code in a separate file. So here it's just using that, it's creating the speech recognizer. So let me copy this. Hey guys, so if you want to use this speech recognition with microphone and speech recognition speech synthesis with speaker, then you have to put this code in your local machine, because from the Azure Cloud Shell, like Azure Cloud Shell cannot access your microphone or your speaker. So you have to paste this code in your local machine and install those libraries again. So I can do that, but right now I'm not doing that. But still, the only difference here in speech recognition with microphone is all the things are same. Just when you are doing this audio config, then when you're setting the audio configuration object, here your speech recognition, then you use default microphone equal to true, right? If you set this use default microphone equal to true, then you can use the microphone as the default audio input. And you can also omit, you could not even use audio config at all. You don't need to use audio config at all, because by default audio input is the mic, default microphone. Default microphone is the default audio input. In case of speech synthesis with speaker, so there also the audio input is basically .audio input config. So here also you can say use default speaker equal to true. By default, if you do not specify anything and if you don't even use audio config, then by default speaker is the default audio output. So you can just omit the audio config altogether. So this is the whole process of speech to text and text to speech lab. Yeah.